So this function like 3x over square root of x minus 12, the domain of this one is from the restriction of the denominator, which in the square root, it has to be positive, number one. So x minus 12 has to be greater than 0. And also the x minus 12 cannot be 0. So it's supposed to be greater than or equal to, but we ignore the equal sign because denominator cannot be 0. So from this restriction, x has to be strictly greater than 12. That's a domain, okay? X such that x greater than 12 for the domain. But the closed interval that's provided is between 14 and 84, which is beyond 12. So then this function is continuous on the closed interval provided. By the extreme value theorem, this function will have extreme values, which means we'll have the absolute max, absolute min within the interval 1484. And then after we verify that, extreme value theorem guarantee is going to have the absolute max, absolute min. Step number one, you're going to find the critical values or the critical point by using the first derivative. Okay, find the critical value. And the critical value can be found by using the f prime as 0, or f prime equals 0 or f prime undefined. Okay, f prime undefined. To find the critical value starting with the f prime, so the derivative of this one as f of x equals 3x divided by square root of x minus 12. This part is the sensitive part of the problem because if you get the wrong derivative, you use the wrong number to get to the end of the problem. We have the quotient, definitely using the quotient rule with the chain rule along the process. The quotient rule back in chapter 3. At this point, I hope you guys are comfortable with all the derivative rules. Otherwise, do something to get practice and to get more comfortable with those derivative rules. All problems in this chapter, you're gonna have to start with the use of the derivative. So the quotient rule, the low D high minus high D low, or the UV version, or the F and G version, whatever version that you are comfortable with, starting with the low, which is the square root of x minus 12, multiplied by the derivative of the numerator, which is 3, minus the numerator quantity 3x times the derivative of the denominator. The derivative denominator, yeah, for our convenience, let's make it in a systematic way. I prefer u and v. Okay, u here, v is square root of x minus 12. I kind of I like to keep everything on the side in case that I have to verify the numbers. So the u prime, we know that's 3. That's simple enough. So the v prime, which is from the x minus 12 to the power 1 half. So v prime is 1 half the quantity x minus 12 to the power negative 1 half, and then multiply by 1. And simplify it to be negative power is reciprocal of the positive power, or the v prime is in the form of 2 times square root of x minus 12. Okay, so I'm going to put it back into the quotient rule formula here on the main part of the problem. So the derivative of the v, which is 1 over 2 times square root of x minus 12, divided by the denominator squared, square root of x minus 12, the quantity squared, and then simplify. Just take your time and you simplify the expression. Do not do it so quick. And I recommend you to pay attention to your algebra because some of you guys misuse the algebraic rule. Okay, like you see something in common like this, you cross it out, which is not the appropriate way to do it. It's not the correct way to do it. I would put it in that way. So from this, let's clean up a little bit. We see the make it as the way that easier to manage. So the square and the square root take care of each other. So I'm gonna take it as the numerator the numerator multiplied by the reciprocal of the denominator. Just make it as not in the complex fraction form. And also I see the common factor 3. I'm going to take the 3 out as a common factor. So then the inside parentheses here as a simplified or the factor form of the numerator as square root of x minus 12 minus 1 over 2 times square root of x minus 12. Okay, just make it in the way that easier to manage. Okay, you can do the way that you have been doing. If it's not the same as what I'm showing you right now, I'm fine as long as you do not misuse the algebraic rule. So what I'm gonna do next, I'm gonna simplify the the difference of the square root and 1 over 2 square root by finding the common denominator, which is 2 times square root of x minus 12. And again, this is divided by 1. So multiply top and bottom by 2 square root and 2 square root to have the same denominator. Now I have 2 times square root. The square root will be gone. Okay, and then minus 1. You can stop me anytime if you have any question. Okay, I'm going to open the chat box just in case you have any question. Next, we're going to simplify the numerator. So 3 divided by, now you can put the denominator here all together as 2 times the quantity x minus 12 square root x minus 12. And then the numerator here is 2 times x, 2 times negative 12. So it becomes 2x minus 24 minus 1. Did I miss anything? I missed x on the top here. So I still need to put the x here. This is the x. And this is the x. Okay. And then simplify the numerator, 2x and x. Subtract, we get 3 times x minus 24 as a numerator, divided by 2 times x minus 12 times square root of x minus 12. So this is the f prime or the derivative of this function. And this is the form that you see as one fraction. It's convenient when you have to work on the critical number, because for the case of the f prime equals 0, you take the numerator 3x minus 24 equals 0, and the case that the f prime undefined, you take the denominator equals 0. So 2x minus 12 square root of x minus 12 equals 0. Because when you divide by anything, you cannot let that thing to be 0. That's why it's going to be undefined case when the denominator is 0. And then what we have to do next, the critical number from the case at f prime equals 0, we have x equals 24. Is 24 located in the interval? Sorry, located in the interval that provided. So it 14 and 84. Yes, we keep this one because this one is on the interval. It has to be internal, or what is it called, the interior point. So it has to be between 14 and 84, not the left end, not the right end. So we keep this value. For the undefined case, we have x equals 12 from both factor here. X equals 12, not on the interval 14, 84. So then we ignore that number. Okay. After you get the critical number, step number 2 of the process to find the absolute max, absolute min, you find the function value at that critical, find the function value at the two ends, which is at 14 and at 84. How to find the function value? Based on the function provided. The function is in the form of, let's make a note here. So from f of x, equals 3x divided by square root of x minus 12. So you just plug it in. So 3 times 24 divided by square root of 24 minus 12. And do the same way for the other two numbers. So the function value at those points, f at 24 as a decimal form is 20.78, and f at 84, they give the same number, which is 29.70. From these numbers, these two numbers, you just see which one is the smallest, which one is the greatest. The greatest is gonna be the absolute maximum value. Value is the function value or the y, and the smallest is the absolute minimum value. Okay, my MATLAB will tell you how many decimal places you have to enter. Okay, if you don't follow the instruction, even though like you have the correct answer, like for example, you're supposed to put in 20.778, but you put like 20.789 and so forth, like keep going, it will not take it or it will not give you the credit. So just pay attention to the instruction. So for this problem, we have absolute max, absolute min, and the graph. And some problem on my MATLAB, they will give you like options for the graph or the choices. So you just pick the correct one. And you can use a graphing calculator to verify. Also, the absolute max, absolute min here between from this window, they see the 0, 100, 5. So that means x started at 0, and the x max for the window is 100, and the increment is by 5. So 5, 10, this one is 10, and then keep going, and so forth. Okay, the increment. And for the second window here, 20 to 30, and the increment is 1. So that means starting with y equals 20, and up here y is 30, and the increment is 1. So 21, 22, 23, 24, 25. Over here, 25 as a scale of the graph. 29.70, that means at x equals 14, so that point, and x equals 84, it's 80, 84 over there. See that we have the same function value. And on the bottom, which is the lowest point of the graph, that's the absolute minimum. The value is 20.78. So absolute, this is absolute max, and this one is absolute min.